This video is similar triangles part 2. We're going to continue where we left off in the last one, and we are trying to see if we can prove triangles similar using angle-angle, side-angle-side, or side-side-side similarity. So in part B here, what we see is we have two triangles. We have this triangle, the small one here, and then we have this triangle, the bigger one. They've drawn them over here for you to the right, but usually you're going to have to draw them yourself. So I would just look at this one right here. Now what I know is they don't give us any angles here. However, this angle L is in both triangles. So again, if you look at the ones they drew, so we have one angle in both triangles. So our only possibility would be this side angle side. So we have some side measurements, so what we need to do is see if the sides are proportional. Be careful if you have to do this yourself, because in this little triangle we have a 6, but in the bigger triangle we have to add the two together. So we have 6 and 9, and over here in the little triangle we have 10, and in the big one we have 15. So we can set up proportions a couple different ways, but I'm going to take the 6 and line it up with the 9, and the 10 with the 15. So I'm going from the smaller triangle to the bigger one, the smaller one to the bigger one. And you can see if you cross multiply here, we're going to get 90 is equal to 90. So yes, these triangles are similar, and they are similar by side angle side. And when you write the similarity statement, be very careful with the order. If you put LKM in the first one, you would need to line that up with LJN. Okay, so let's look at our next example. So in C, what I notice here is that I do not have any angles. And again, they drew this for us, but let's look at it ourselves. We have this triangle, and then we have a bigger triangle. And what you're going to look at is you want to look at the sides. And so I see that this 3 in this smaller triangle has to line up with the smallest side in the other triangle. So that is 6. And then the 5, the middle measurement, needs to line up with my middle measurement here, 10. And that leads this 6 to line up with this whole side, which is you have to add 6 and 6 and get 12. So what we can do is we can just set up ratios, the 3, the small side, over the 6, the 5 over the 10, and the 6 over the 12. And what I notice is that I have a scale factor of 2. 3 times 2 is 6, 5 times 2 is 10, 6 times 2 is 12. So yes, we have similarity. It's side, side, side similarity. And now when you put them in order, be very careful. C, D, G lines up with E, F, C. Okay, the next example, example 7, is a little different. Well, just a little bit. We have this triangle, which is, we have measurements of 3, 4, and Y. And then our bigger triangle, well, on this side of our bigger one, we have a 7. On this side, we have an 8. But on this side, down on the bottom, we added 3 and 4 and got 7. So on the top, we have to add x and 3. And so we just have x plus 3. So on this one here, I would probably use a proportion and not scale factor. So I'm going to take my 3, the measurement on my small triangle, and line it up with the corresponding measurement on my bigger triangle, which is x plus 3, and set that equal to 4 over 7. And when I cross multiply, make sure you put that in parentheses. You're going to get 21 is equal to 4x plus 12. If you subtract 12, you get 9 is equal to 4x, and x is equal to 9 over 4. And it's fine if you just leave it as 9 over 4. Okay, now to get y, we're going to go ahead and take this same 4 over 7, the small one, with the bigger one, and set that equal to y over 8. We get 32 is equal to 7y, and we divide by 7, and we get 32 over 7. And it's fine if you just want to leave it as 32 over 7. This really isn't a quick check. They just drew the picture over there for you. So please pause this one for a moment and see if you can do this one yourself. Okay, what I notice here is in my small triangle, okay, those are the same. Now, I don't know for sure that it's similar. I'm trying to see if I have enough information, but this angle right here, C, is also in the big triangle. And this shows that this measurement is the same. So we have isosceles triangles. And there's a rule about isosceles triangles that says that the sides opposite these angles here have to be congruent. So if I look over here where they drew it, 6 and 6, so y has to be 4.5. Because they have to be the same if these angles are congruent. So I already know y, so we just need to find x. So you can, probably the best here would be a proportion. I can just put x over 3 is equal to 6 over 4.5, and I get 4.5x is equal to 18, and then I just divide by 4.5, and let's see, 18 divided by 4.5 is 4. So x is 4 and y is 4.5. And we're actually going to stop here. We're not going to do the hinge theorem at this time. So that's the end of the video.